Hi there, welcome to my channel. Hope you're doing well. In today's Leetcode problem, we are going to solve this medium categorized question, which is 852. Its title is Peak Index in a Mountain Array. So let's understand the problem first. It's saying an array is a mountain array if it holds the following properties. The first property is its length is greater than 3. And then it's saying there exists some I is the index, which is within 0 to length of array minus 1, such that element at index 0 is less than element at index 1, and so on. And element at index I minus 1 is less than index at element at index I. If we see this, all the elements here are in increasing order till element at index I. Now the second property is element at index I is greater than element at index I plus 1, and this is going till index at length minus 1. So all the elements after I are in decreasing order. So if I try to say this is like 1, 3, 6, 7, now 5, 3, 0 till 7, all the elements are in increasing order and less than element at ith index, and all the elements after ith index are then in decreasing order. So this is a mountain array. Now the problem is we are given an array. We have to return the index I such that this property holds. Now if we take this example, in this case it must return 0, 1, and this is 0th element, 1, 2, 3. So 3 should be the output. Now they are saying you must solve it in order of log array dot length time complexity. That is order of log n time complexity. We will see that. Now if we see the examples, for example here, 1 is that element which is at the peak of the mountain. Now for this element, it should return 1 because it is at index 1. In this example, 2 is that element which is at the peak of the mountain. So again 1 is returned as its index value is 1. In the next example, 10 is that element which is at the peak of the mountain. So again 1 is returned as its index value is 1. Now the constraint is about the length of array and value of its elements, and we are given that it will be guaranteed a mountain array. So we don't need to cover the case where the array itself is not a mountain array. So to start with, the easiest thing that comes to anyone's mind is to have a loop from index 0 till index length of array minus 1 and try to find out an index, for example I, where this element at index I is greater than element at index I plus 1, and also this element I is greater than array index element at index I minus 1. So whenever this condition is met, we can return the ith value from here. But now, because for example, if I'm using a while loop here, so now it will take a complexity of order of length of array. Okay, which is equivalent to, if we say in generic, it is order of n. But now the question is asking us to solve this in order of log n time complexity, like this. To solve this, what comes first to our mind? So if we think which algorithms actually returns this time complexity, first thing comes to our mind is binary search. In this example, if we apply the binary search, we will land at the mid. If please go through the binary search algorithms first if you are not aware of that. But in general, in binary search, we calculate a mid and we see if mid is that element which we are looking for. And if it's not that element, then either we look in the first half of the array or the second half of the array. So at each iteration, we keep dividing the array into half. So if we check this example here, at first only mid will be 3. So in this case, mid will be 3. So in this case, the problem will be solved in order of one case. one time complexity only. So this is the best case for a binary search, but the average case is order of log n. Let's try to solve this using the binary search. Now we will have some start. Let's start from 0, and then we will have one end element. Now the end element will be length of array -1. So we will traverse from 0 to this end, start to end. Now let's take mid as 0, or we can take as 1 also, because it will always have at least 3 elements as stated somewhere here. So let's take it as 1. Now we will have a conventional while loop for binary search. While start is less than n, we will calculate the mid. So mid will be start plus n, and both divided by 2. So now we will write this condition here. If array at mid is greater than array at mid -1, and array at mid is greater than array at mid +1. If mid is that ith element, then we will return the mid from here itself. Now what if mid is not found? Now if mid is not found, we have to update the start, either start or the end, for that the next iteration of binary search. Now if element at mid is greater than element at mid -1, in that case we will set the end to mid. In the other case, we will set the start to mid. This will be mid +1. At the end, we will return the mid value. Let's try to run this. Okay, it is saying wrong answers in case 2. The output is 2, which should be 1 expected. Let's see what's wrong here. Okay, I found the mistake here. I wrote this outside the bracket. Now this is fine. Now let's run again. Okay, now all the cases are accepted. Let's try to submit it. Okay, this is submitted. Now we already have talked about the complexity. Its time complexity is order of log n, where n is length of the array, and its space complexity is order of 1 only, because these are the fixed variable start, end, and mid, which we calculated during this problem. That's all about this problem. If you want to see more Leetcode problems, you can visit my channel. If you have any better solution for this problem, please do comment in the comment section. Thank you so much.